Part two, this is going to be looking into how to tackle the examples that are on your sheet. So this second video should help you with that. We're going to be looking again as a reminder into quartiles and IQRs and outliers. So consider this data set here. Numbers already listed from smallest to largest. What we're going to do is look for the upper quartile, the lower quartile, Q3 and Q1, and determine the IQR, so the difference between Q3 and Q1. So when we tackle this, we want to make sure that we can identify what the middle is. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data numbers. So we're going to go 1, 2, 3, 4, 5. We're going to split that in half. Obviously our Q2 is going to be 7. Because we don't have a solo number in the middle, we don't have to omit anything. We've got the left-hand side and the right-hand side. This is a nice easy one because our Q3 is just one solo number and our Q1 is just one solo number. So Q3 is equal to 13 and Q1 is equal to 4. So our IQR in this case is going to be the difference between 13 and 4, which we get 9. Nice and easy. Now, example 11, we're going to do the same thing, but we're just going to see a variation with what the types of numbers that we'll get, and more specifically, how we can determine Q1 and Q3, depending on what our end value is, how many numbers we have. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 numbers. A mistake that some kids fall into is making sure that they have to put these numbers in order from smallest to largest. They just go straight to it, look at the back of the book, or look at their solutions and wonder, the hell am I doing wrong? You have to put this in order from smallest to largest. So now that we've got this from smallest to largest, we can go ahead, find what our Q2 is. So because we've got 9 values, our first, second, third, fourth, fifth one is Q2. This gets omitted, so we just ignore it for now. Then we can find our Q1, which is in the middle of a second and third, and Q3, which is in the middle of a fifth, sixth, seventh, and eighth. So to get Q1 in this case, it is 1.8 plus 2.2 divided by 2. So in the middle of that is exactly 2. Now let's be specific and consistent. Try 2.0 because it's to one decimal place. And then again, this is our Q1. And then again, for Q3 is adding 3.6 to 3.8, dividing that by 2, we end up with 3.7. So to answer what our IQR is, it is just the difference between Q3, which is 3.7, and Q1, which is 2, so we have a 1.7 as our IQR. So if we just have a pause and just look at this, that just means that the middle range ranges from 1.7 as opposed to the big range. We care about what that middle range is, and then we're going to use this calculation IQR further down the track to be able to determine outliers through that formula that was provided in the first video. Now, our final example, it's a bit of a chunky one here, 4 parts. We're going to be looking into the following data that represents the number of flying geese spotted on each day of a 13-day tour of England. Very specific niche data. For this, we are going to look at the minimum, maximum number of geese, the median, the upper and lower quartiles, and the IQR. So hopefully by now you should know how to tackle these types of questions, especially the minimum, maximum, and median. This is something that we should know off by hand. Now, if you haven't done so yet, you've got to make sure that this is put into order from smallest to the largest, because the data in the set isn't. So when we put this in order, all of a sudden we can see something's going on here, and it might be an obvious outlier to some. To others, it's like, oh, 18, nice, that might belong to the set. We'll see. Now, 13 days, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's good to double check that you have 13 numbers. We're going to be looking into what the median, minimum and maximum. So min, that's a simple 1, max 18. Even though it's considered an outlier, you still write that the max is 18. Where we disregard this when we're trying to show this visually is when we make a thing called a box and whisker plot or box plots. We'll hone into that later down the track. The median for this case, so because there are 13 values, we are looking at the 7th value. Now, if the number is odd, I just add 1 to it and then divide it by 2. So 13 plus 1 is 14. Divide that by 2 is 7. 1, 2, 3, 4, 5, 6, 7. That right there is our median. So median is equal to 4. The upper and lower quartiles, because we have one solo number, we omit this for now. 1, 2, 3, 4, 5, 6. So we're looking at 2 middle numbers there. 1, 2, 3, and there. Hopefully by now you can do something as simple numbers like this. We can write a Q1 straight as 2 because we know it's 2, and our Q3 as 5.5 because we know it's 5.5. IQR, difference between the two, which is equal to 3.5. So our middle range varies 3.5 units. Now, B is asking to find any outliers. So I'm expecting that this number here, 18, is considered an outlier. Now, how we do this is, even though it's a high number, we still got to make sure that these low numbers are considered outliers as well. So we're going to look at our lower fence. So LF is our lower fence, and if you can recall, this is getting what Q1 is and subtracting 1.5 lots of the IQR is. Now, we've already worked out the IQR is 3.5, and our Q1 is 2. So if we get 2, and we minus this from 1.5 lots of 3.5, in other words, 2 minus 5.25, anything that is considered lower than negative 3.25 geese is considered an outlier. If you get a negative number, don't freak out, especially if you're expecting a whole number, because we're dealing with countable real-life geese. This is just a formality of calculations. So anything lower than this is considered an outlier. Clearly, we don't have anything lower than negative 3.25 because our lowest number is 1. But for the upper fence, what we're going to do is we're going to get Q3 and add 1.5 lots of the IQR just to determine if that 18 is considered a high number. So 5.5 is our Q3, and we're going to add 1.5 lots of 3.5. So in other words, 5.5 plus 5.25, which gives us 10.75. Any numbers that are higher than the upper fence, so higher than 10.75, is considered an outlier. And lo and behold, 18 is an outlier. So we have found our outlier, so we have to specify 18 is the outlier. Now the last question is, or second last question rather, can you give a possible reason for why the outlier occurred? In the context of geese, this is a bit of a tricky question. So creativity, holds its key to this answering this question. There's no wrong or right way, but maybe there was a flock of geese that was found within that particular day, or I don't know, there was just geese up in a tree and they all decided to fly. Who knows? Flock of geese at some point. Maybe it was, I don't know, maybe they went to a zoo. We don't know. That's a possible reason. There's possible reasons. So don't stress out about a specific way. Don't go into Google and be like, why was more geese found? All right, last question. If the outlier's value is corrected to 8, determine the range and IQR of that data set. Explain the similarities or differences compared to the original data set. Now, I'm not going to show you the working out to this, but if that outlier value is corrected to 8 as opposed to 18, that will have a massive influence to what the lower fence and the upper fence range is, because your IQR is going to potentially change. But because 18 is the last number, if that does change to 8 and it is the highest number, the IQR in this case is going to stay the same. So Q3 is still going to stay the same. Q1 is still going to stay the same. And so what will happen is we will be looking for any numbers that are greater than 10.5, because 8 isn't considered higher than 10.5 but rather lower, it is not an outlier. Similarities or differences. Similarities, everything is the same. Differences, 8 is not considered an outlier. Alright, set of questions that you have to do can be found at the bottom of the page. Best of luck with the questions, and I'll see you guys in Friday's class.